everyone, this is Sirius Minds, back here again with another video. Today we are looking at a question from the October/November 2013, paper 2, question A6, part A. Right, let us take a look at this question. Aspirin is a medicine that is used as a painkiller. It is made from salicylic acid. A student makes a sample of aspirin. He thinks it contains some impurities. The student then tests the melting point of his sample of aspirin. And the question wants us to explain how he can use the result of this test to find out whether his sample contains any impurities. So remember that we can test the purity of a substance not just through melting point or boiling point. We can also actually test it through using chromatography, right? But this question is asking us on how can we tell the purity based on just the melting point or boiling point, and in particularly this question, melting point, of course. Right, so how do we tell from the melting point if something or a sample is pure? Always remember that when it comes to the melting point or boiling point, if a sample is pure, alright, pure sample, then we will expect the melting point and boiling point to be fixed, meaning to say it melts or boils at particular one fixed temperature. For example, water will boil at 100 degrees Celsius and melts at 0 degrees Celsius. That is for pure water. However, if let's say we add some salt to the water, then we will expect the melting point to be below 0 degrees Celsius and the boiling point to be above 100 degrees Celsius. So how can then we answer this question, right? So we will go like this. If the sample melts at a fixed temperature, the sample is pure. If it melts over a range of temperature, it contains impurities. Right, so you can see that 2 marks is awarded for this question, and from the way we answer it, 1 mark is given when we mention that the sample is pure when it melts at a fixed temperature, and the other mark will be awarded if you mention that it melts over a range of temperature if it contains impurity. Okay, and that will be how we answer part 1 of this question. Alright, so now we are going to look at the second part of this question. The student uses chromatography to produce a chromatogram. He uses his own aspirin and a pure sample of aspirin and salicylic acid. The diagram shows his chromatogram. What information does the chromatogram give about the purity of the student's aspirin? So recall that when we are doing the chromatography experiment, we actually uses some known sample and also an unknown sample. Then we will base on the spots of the known sample to determine the composition of the unknown sample. So in this case, it's very similar. We can see that there are 3 samples being used. One is the student's aspirin, the other one is the pure aspirin, and lastly we have a salicylic acid sample as well. So let us start to dissect the chromatogram. As we can see, this spot is from pure aspirin, and if we align it to the student aspirin, we can see that there is one spot that is aligned. And then next, when we take a look at the spot of the salicylic acid and we align it to the student aspirin sample, we can see that there is also a spot there that matches the salicylic acid spot. Last but not least, we have this third spot over here, which is an unknown because there's no other sample on the right side of this chromatogram. Right, so what does this actually tell us in terms of the purity of the student aspirin? Right, so it goes like that. The chromatogram shows that the student's aspirin is not pure. Alright, this will give you 1 mark, and then now we need to use evidence to back up our answer. It contains salicylic acid that was left over and an unknown spot that does not match pure aspirin or salicylic acid. Alright, so by answering it this way, the first mark comes from here, whereby you actually mention what the information of the chromatogram tells you about the purity, and you get another mark here by using evidence to back up your answer. And I also realized a small mistake here. This should not be is, but that. Right, so this is how you should answer for this particular question here.